Okay, class, this is going to be the last section of Chapter 7, 7.5, Systems of Inequalities and Linear Programming. A lot of this you've probably done before in other classes, so hopefully that this can be a bit of a review for you guys. First, there are a couple steps that I just want to highlight for drawing the graph of an inequality in two variables. I apologize for the handwriting, so hopefully you can make this out. But the first step is to replace the inequality sign with an equal sign in graph. Okay, so that is replace an inequality sign with an equal sign, right, and then go ahead and graph that. Remember that the less than and greater than, we're going to use the dashed line, and then a less than or equal to and a greater than or equal to, we're going to use a solid line. All right, so that's the first step. The second step is to then pick a test point, and usually the test point that we use is 0, 0. If the point satisfies the inequality, so we're going to pick a test point, plug it into one of the original inequalities, and then if that point satisfies the inequality, we're going to shade the region containing that point. All right. So example 1, we have to draw the graph of y that's greater than or equal to 2x plus 3. All right, so the first step is to replace the inequality sign with an equal sign and graph it. So that's going to be y equals 2x plus 3. The y-intercept is 3, so we're going to go up 3. That's our y-intercept, up 3 on the y-axis. And then our slope is 2, so we're going to go up 2 over 1. Up 2 over 1. And then we're going to go down 2 to the left 1, and so on. All right, that'll be good enough for this problem. It is greater than or equal to, so that means we're going to be using a solid line to connect the points. And there's our graph. Now, the second step is to then pick a test point. All right, the test point that you're usually going to use is 0, 0. The only time you wouldn't use 0, 0 if the line or your graph goes through the point 0, 0. So then you'd have to pick another point, and we'll see an example of that here in a bit. But we're going to pick 0, 0. So we're going to plug in 0 for y, and we're going to plug in 0 for x. All right, so we have 0. Oh, I'm sorry, and we should replace this equal sign with the original inequality. So we're going back to the original inequality, so we want greater than or equal to, greater than or equal to, greater than or equal to. So is 0 greater than or equal to 3? All right, so here was the point 0, 0. Is 0 greater than or equal to 3? And the answer is no. All right, so we are going to shade then away from that test point. So this is the area that contains solutions to the inequality. All right? So hopefully you guys remember how to do that from past math classes. All right, this is not on your slides, but I just want a quick refresh. Want to graph x is greater than or equal to 2, just so we're good with this, because this confuses some people sometimes. So x greater than or equal to 2, that is going to be a vertical line through x equals 2. So it's going to be this line right here. Every x coordinate on that vertical line is 2, so that's why it's vertical. Again, we would pick the test point, 0, 0. Alright, so is 0 greater than or equal to 2? The answer to that is no, so we would shade away from the test point. So that's all this over here. Alright, and then y less than 2. So that's this horizontal line right here, and this should be dashed because it's less than, so let me undo this. Oops. This should be a dashed line. Ooh. Okay. Plug in the point 0, 0. So 0, is that less than 2? And 0 is less than 2, so we're going to shade below. Alright, so I just wanted to do these examples just so you don't confuse how you would graph those particular inequalities, because they can be confusing. Alright, example 4, solving a system of inequality graphically, and in this case we have inequalities that aren't linear. Alright, so how do we go about doing a problem like this? So let's, and you guys can, if you guys are good with your graphing calculator, you can do these. There's a way you can look it up online, but you can do these on your graphing calculator. But you know, we're going to do these by hand here. So y greater than or equal to x squared. So we have to graph y equals x squared. Oops. So y equals x squared. So if we pick the if we just pick some x coordinates, plug it in and get y. So if we plug in 0 for x, we get 0 for y. If we plug in 1 for x, we're going to get 1 for y. If we plug in -1, we're going to get 1. If we plug in 2, we'll get 4. If we plug in -2, we will get 4. Alright, if we go back, it's y greater than, so we're going to connect using a dashed line. Alright, pick a test point. So let's do 0, 0. So is 0 greater than 0 squared? And here you see that this graph goes through the point 0, 0. So this is an example of where you can't use 0, 0 as your test point. Alright, so we have to now pick another test point. Alright, so let's make that test point 0, 1. So 0, 1, let's do 0, 2. Alright, so let's do 0, 2. Let's test that point right there. So we have 2. Is that greater than? No. Is that greater than 0 squared? So is 2 greater than 0? And 2 is greater than 0. So we would shade this area in here. Alright, now we'll go back, and now we have 2x plus 3y. That has to be less than 4. So let's go ahead and solve for y. Replace the inequality with an equal sign. So you have 2x plus 3y less than 4. So we have 3y less than negative 2x plus 4. Divide by 3, so we have y. Let me replace this. Let's follow our rules, replacing that inequality with an equal sign. Alright. Alright, so divide by 3, so we have y equals negative 2/3 x plus 4/3. So we have to graph that. So negative 2/3 x plus 4/3. So y, let's write this down here. Y equals negative 2/3 x plus 4/3. Alright, so 4/3, 1 1/3. Let's get rid of that point. We don't need it anymore. So 1 1/3 puts us about right here. And then we're going to go down 2 to the right 3. So 1, 2, 1, 2, 3. Alright, and then we'll go up. And then over. Alright. And then we're going to connect. What are we going to connect with? We're going to connect with a dotted line. Alright. Pick a test point. Okay, so let's do 0, 0. So 2 times 0 plus 3 times 0. That has to be less than 4. So is 0 less than 4? Yes, it is. So we would shade towards the test point, which would be this area right here. So those are all your solutions. Alright. Okay, example 5. So example 5, we continue to kind of, all these example problems basically build on each other, and the end goal is to solve a linear programming problem at the end. So this is one where we have 1, 2, 3, 4 different inequalities that we want to graph. These right here, y greater than or equal to 0 and x greater than or equal to 0, those basically tell us that we're just going to be graphing this inequality in quadrant 1. Most of the linear programming problems, they're kind of real-life application problems, and your x's and your y's, those are going to be positive numbers. So for most linear programming problems, you're going to be dealing in quadrant 1. So this right here, those inequalities put us in quadrant 1. So let's go ahead now, here and here. Let's graph those. So let's solve for y. Replace the inequality sign with an equal sign. So 2x plus y equals 10. Subtract 2x, so y equals negative 2x. Plus 10. Alright, so let's graph that. So there's quadrant 1. I'm not going to label these to keep it neat, but these all go by 1. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there's the y-intercept, which is 10, and then it's negative 2x. So negative 2 is your slope, so we're going to go down 2 over 1. We connect with a solid line. Let's see if this works. Yep. Cool. Alright, pick a test point. So we will, let's do 0, 0. So, oops. So we have 2 times 0 plus 0. That has to be, is that less than or equal to 10? So is 0 less than or equal to 10? Yes, it is. So we would shade that area right there. Alright, let's erase this. And then let's solve for the next equation, or inequality. So, replace the inequality with an equal sign. 2x plus 3y equals 14. So we have 3y equals negative 2x plus 14. So y equals negative 2/3 x plus 14/3. Alright, so 14/3, that's 4 2/3. 1, 2, 3, 4. Oops. Right there. 1, 2, 3, 4. Yeah. Alright. So let's make this. It's hard to draw dots on this thing, so. Alright, so 4 2/3, there we go. Let's go back. Our slope, negative 2/3. So we're going to go down 2/3. So 1, 2, down 2. Alright, we're going to connect with solid line. Alright, pick a test point. So 0, 0. So 2 times 0 plus 3 times 0. Is that less than or equal to 14? So 0 less than or equal to 14? Yes, it is. So we would shade everything in here. Alright. Okay. Onward. What do we got? Okay. So, like I said, all these problems build up to a linear programming problem, which is going to be our last example. So linear programming. Sometimes decision making in management science requires we find a minimum or maximum of a linear function, and this is called an objective function. All right. So such a problem is a linear programming problem. All right. So we are interested in linear programming problems. You're essentially interested in finding minimums and maximums in real life. You're interested in finding minimums and maximums, finding a max if you're trying to maximize your profit, if you're trying to minimize your cost. So these are real relevant problems that we're going to be doing here. We are going to keep it very basic, since we're not in school. I don't want to get too complicated, so we're just going to keep it real basic, and we're going to finish with example 6 here. Example 7, it's a little bit more, in depth. If you're interested in kind of, those types of problems, example 7, you can kind of research it on your own. But for the sake of what you're going to be tested on with linear programming, we're going to keep it super simple. And example 6. So example 6 is as hard as it's going to get on your test here. All right, so let's do this one. So it says find the maximum and minimum values of the objective function f equals 5x plus 8y, subject to the constraints given by the system of inequalities. So constraints, so these are all your constraints. All right, you can think about your constraints of what you're kind of restricted to, the resources that in real life that you'd be restricted to using. So those are your constraints, and then right here is the objective function. and we'll come back to this in a minute, but let's first go ahead and graph all of our constraints that we have here. So we know that because x greater than or equal to 0 is a constraint, along with x greater than or equal, did I say y greater than or equal to 0 and x greater than or equal to 0, those are two constraints, so we know we're going to be dealing in quadrant 1. And these constraints here, all right, we already graphed these in the previous problem, so this is going to be nice. So if we look, all right, I basically redrew the graph that we had in example 5, and again, these linear programming problems, we're interested in finding minimums and maximums. Well, the cool thing about these things is that at the corners or at the points or at the vertices of your feasible region. So your feasible region, okay, that's a vocabulary word you're going to see. Your feasible region is kind of the region where it's in yellow here. It's where your solutions lie. So at the vertices of the feasible region, or at the corners, that's where your minimum or maximum values occur. So I circled those corners, those vertices in red with the red circle, and the points I wrote as ordered pairs. All right, so this point right here, that's the ordered pairs 0, 14 thirds. Here, this point is obviously 0, 0. This point right here is 5, 0. And then this point right here is 4, 2 thirds. Now, what you could do, and what I would recommend doing, is taking your graphing calculator and entering in. Go ahead and solve for y for these two equations. So you would say y equals negative 2x plus 10, and then for this one you're going to have, what did we get? We had 3y equals negative 2x plus 14. So we would have y equals negative 2 thirds x plus 14. So in your TI-83, go to your y1, put this in. Go to your y2, put that in. And then find the intersection. Go to, let me get my calculator here. So you would go, once these are in, once those are in, you would then go to you'd go to second trace. You'd scroll down to intersect, and then there'd be a cursor. It'll say first curve, that'll be on one of your lines, hit enter. Second curve, that'll be blinking on the other line, hit enter. Guess, and then it'll tell you the intersection point. So that'd be the best way to find out what some of these some of the points that aren't as obvious are. All right, so can use I use the TI-83 calculator to find that point. Okay, so once we have all the points now, we are going to plug them into our objective function. So so you'd take 0, 0 and plug it in. So 5 times 0 plus 8 times 0, what's that going to give us? That's going to give us 0. 0 and 14 thirds. All right, I did this. If you plug in 0 for x and 14 thirds for y, you're going to get approximately 37.3 repeating, so 37 and a third. You plug in 4, 2. What are we getting with 4, 2? We're getting 36. And then 5, 0, you're going to get 25. All right, so that all I did was I took these points, okay, and plugged them in for x and y into our objective function. So as you can see, your minimum would be 0. Your maximum would be 37 1/3. So in order to maximize this particular problem, your x would have to be 0 and your y would be 14 thirds. And then to minimize, your x would be 0 and your y would be 0. So that's a wrap on chapter 7. All right. Like I said, our test is going to be coming up here on Friday. So I hope this helps, and we will see you in a bit.